Station 8. Does the light that travels from your teammate's face to your eyes travel in a straight line path or curved path on each segment of its trip? Example, face to face, mirror to mirror, etc. Um, for my partner and I, it was face to face because we had to angle our mirrors a certain way so that we were actually able to see each other's face. So it was like held upwards at an angle because he's taller than me, so we had to angle our mirrors perfectly so we could see each other's face. Station 9. Why did hydrogen and the ceiling light have similar but different observed rainbow patterns? Um, I think it's because the visible light, uh, electromagnetic wave has a lower frequency than ultraviolet lights. So because of that, ultraviolet because they're not the same, ultraviolet light interacts with the atoms uh, on the same natural frequency in a different way. So the vibration amplitude for an ultraviolet light, uh, its electrons they become unusually large, unlike a regular visible light. Station 10. What is happening to the laser light that causes it to stay in the plexiglass tube until the tube's end? Um, the beam of light is coherent. So when we would stick the laser to one end of the plexiglass tube, um, a light the light wave emitted from one atom stimulated the emission of light. So a neighboring atom from light from a neighboring so that the crests of each wave coincide. So it was like the laser was controlled throughout the whole tube, so it just like went around in circles. So it went into the shape of the tube. Station 11. How does a 3D movie work similar to the observations at this station? Um, uh, it's because 3D movie uh, project projects the pair of views through polarized filters, so their polarization axes are at right angles to each other, just how when I would rotate our polarized filters. And so uh, to watch the 3D movie, uh, people wear these like 3D glasses or whatever, and the glasses polarization axes are also at right angles, and it's like the glasses that we are wearing. So it's the axes of the polarized filters on both 3D movies and the filters that we had. They're both the same, and that's what connects a 3D movie to that station. Station 12. How does the fact that hydrogen, sunlight, and the ceiling light have different rainbow patterns help scientists studying distant nebula, stars, and galaxies? Um, that helps the scientists because the nebula, stars, and galaxies probably have the same makeup as the hydrogen, ceiling light, and sunlight, so that they have the same rainbow and like the same colors, like because I know that when we went outside different colors showed. So when scientists are looking far away at stars and galaxies, they can see that the colors that are showing and the direction in which the rainbow is going, they can connect it to the sunlight and stuff. So by being able to make those connections, they're able to be like, oh, since galaxies and sunlight have the same rainbow and like the same colors in the same direction, then what I'm looking at right now must be a galaxy. So I think that's how they do it to help them out. Station 13. What is the difference between the effect of an outwardly curving lens and an inwardly curving lens? The difference is that in outward lens, um, the laser starts out really jumbled and mixed together, but as soon as it goes through the lens, the light straightens out into perfectly straight lines. And when the lens is inward, the light starts off really straight, but as soon as it goes through the lens, it flares out. So instead of being, it's kind of like at an obtuse angle. The rays on the lights on the outside are at obtuse angles, and how is this helpful to eye doctors? This is helpful because when you go to the eye doctor, they like put lenses in front of your eyes and they click through all the little stations and they ask you, "Oh, is this lens better or is this lens better?" And I think it's because the lenses are all curved a certain way. So by asking those questions, they're able to see if a outward lens or an inward lens in to what degree of how outward and inward is. I think that's how it helps outward and inward lenses help doctors with giving out glasses and stuff. Overall, what did you think of the light tricks lab? This was really fun. I liked how we went to all different stations and we just kind of like we kind of walked through it ourselves, and I really liked that. Like it helped me to learn it better because I had to think, but then like I didn't have a crutch, and I kind of liked that. And I thought it was fun how it was one big lab, but there's 13 stations, so I got to experience new things. It wasn't like really a long lab, and we had to do steps 1 to 20, and it was the same thing. So it was really fun, and there wasn't really much repetition, so I really liked that. Was it a worthwhile learning experience? I think so. I think I remember this lab the most because I had the most fun with it. Um, I just thought learning about lights and how like lasers and all that, the directions and just stuff and like polarized filters. I thought that was a lot of fun. And doing those short mini stations or labs in the whole lab, I thought that was a lot of fun.